this is what is the virtual machine, and let me just go ahead and start it, and at least show you how it looks like. Don't worry, today we won't do much on it. Probably tomorrow also we won't do much work on it. So you have, a couple of days to get this up and running on your machine, but do it as soon as you can, because doing hands-on along with me, if you can do it along with me, it would look something like this to you. A shell would open, and let me not talk about it right now, just not to overwhelm you right about what the software looks like and all that. So I am going to do this. Okay, let me do this. Just give me 1 second. I'm just going to put this here, and yes, we're done with this. Yeah, so let me get started. Okay, all right, so let's take this first example. As you can see my screen right now, right? You would have seen the cricket telecast on TV, right? Or on your Fire Stick, or nowadays you see this in your Hotstar, right? Or your Sony Live. When you watch sport, right, like cricket, nowadays you get a lot of statistics around it. Recently, the IPL got concluded, and you would see a lot of statistics going around, right? If you are like me and interested in cricket, you would be able to relate it to your experience, right? So something like keys to success, for a team, right? Let me just take out this pointer, a very useful pointer over here. Keys to success for a team. So if, for example, Rohit Sharma will hit a century, there is a highly likely chance that Mumbai Indians is going to win them, right? Or if Bumrah is going to take 4 wickets, or some 15 dot balls, there is a highly likely chance that Mumbai Indians is going to win. Not to say that I'm a Mumbai Indians fan. I'm a cricket lover, so I love like all the teams. So keys to success to the team, right? Ball trajectory. If you've seen test matches, right, you would see that if somebody is bowling, let's say the test match is going on in UK or London, England, ball swings a lot. So how much it is swinging and how difficult it is to bat. Those kind of things. Or for that matter, in DRS also. Direct review system in cricket, you would see that somebody is appealed, and it is going to a review. The umpire is going to see the ball trajectory is to to what extent, in what direction the ball is going, right? The reason I'm telling you, my dear friends, all these examples is because this is somehow connected to big data. There is huge amount of data on the basis of which there's a lot of analysis has been done, right? And how it is done is something that we are going to understand out of this string, right? I'm just telling you the examples right now, that this is what is done and this is what we see in our day-to-day life, right? Batsman strong or weak zone, right? If you give an overpitch delivery to, without getting into too much details, if you give an overpitch delivery to somebody like Rohit Sharma or Virender Sehwag, he might have problems playing, right? Run scoring graph, who has played what? Yuvraj Singh hits on the mid wicket. So those kind of things. Bowler speed, swing, wicket taking delivery, right? You can see that in other sports also, right? Like tennis. Now see, nowadays if you watch a Grand Slam or any tennis match on TV, you will see that there's a lot of statistics that is going to come into picture, on your screen. The number of aces, half volleys, backhand, forehand, down the line, all those kind of things. My point is, as I said, all this information, all these broadcasters or telecasters are able to present to you because they are saving huge amount of data, and they are constantly analyzing it. And the reason why they are analyzing it, so that the experience, the viewing experience for end users like me and you becomes much more fulfilling, becomes much more complete, right? That's the reason why, right? That's one example. I started with the sports domain example because that is something that we all can relate to, right? Because we all are interested. But these examples are not only restricted to the sports domain. There are other domains as well in which it is useful. In fact, usefulness of data has extended to almost all the domains at this point of time, my dear. All the domains, as you will see, and as I'm going to slowly unfold, these examples to you. Right, Facebook, right? Facebook, more than 1 billion users, actually more than 1 billion users at this point of time, right? As I'm giving this presentation, all of us use Facebook. Generates close to, look at the amount of data that these companies are generating, right? It is not in GB, it is in TB, 100 terabytes of data per day. Imagine where would they be storing it, and how would they be storing it, and how they would be managing it. And what do they do with that data? They do that to improve their product. So I'll give you an example. 10-15 years down the line, 10 years before, in 2005, 2006, when Facebook came, it was a plain bare bone wall kind of application where you can go and post your pictures and post your status messages. That was it. Over the course of last 10 to 15 years, Facebook has emerged as a major business platform. You can run your business from Facebook, right? That's what Facebook has emerged into. And the reason why it has happened is because they've been constantly not only saving their data, but they are also constantly analyzing that, right? Analyzing that data, and then analyzing the data to make business decisions. Now, see, I'm using these important terms over here, my dear friends, right? Using data to make decisions. At some point of time, I'm going to, present the definition of, what is big data, right? Definition of what is big data. Then you would be able to relate to whatever I'm telling even more, right? I'm actually guiding you towards that, that formal definition, and then related to, the big data technologies and those kind of fires 70,000 queries on that data every day. They have something, Facebook has developed a software, big data software called as Hive, Apache Hive, using which it gives an SQL kind of interface to your data, right? And you can fire queries and get analysis, get output out of it, right? They are the inventors and one of the biggest users of Hive, right? So these companies like Facebook, Uber, Netflix, I'm going to talk about Netflix also a little bit in some time from now. They have their separate engineering division, where this division just only works about working on the data, churning the data, saving the data, and they also develop technologies like Facebook had developed Hive and a lot of other softwares, big data softwares as well. Uber has also done the same thing. Netflix has also done this, right? Moving on, Walmart, an example from the retail domain, right? About whatever this figure is, $485.651 billion. I've taken this from Wikipedia. They are retailers, right? One of the biggest retailers. They have a investment in Flipkart also, as you might be aware, here in India. Handles more than, look at the amount of transactions, right? Handles more than 1 million transactions every day. Imagine the amount of data that they might be producing, right? At some point of time, I'm not saying all this is unique information. I'm pretty sure you would have read, seen, heard this somewhere or the other. I'm just trying to put this into the context of this training, my dear, right? So US 485 point US dollar 485.651 billion US retailer handles more than 1 million transactions every day, produces more than, what is that, 2.5 petabytes of data on a daily basis, petabytes. And that is what you're going to see about big data, my dear friends. It's not about MB or GB, right? It's about, terabytes and petabytes of data. That is where the game begins, right? Somebody was asking me the other day, I was giving this presentation, and somebody said, big data, how big is big? I said, tell me, what machines do you use? He said, I have a laptop at home and I have a desktop in the office. I said, what is the hard disk capacity of your laptop? He said, 1 TB. I said, any data which is more than 1 TB, that is, your machine, your laptop cannot store that data. That is big data for you, right? If your desktop has got 2 terabytes or 4 terabytes of hard disk, any data which is more than that, any data which needs more than one machine to save, right? These are very important statements that I'm making. I'm going to relate it to the definitions that I'm going to be presenting to you, my dear, right? In a very short while from now. That is big data. You see what I'm saying, right? Walmart has got dedicated data centers across the world to handle their order. They have one in Bangalore. You would see this data center on Outer Ring Road, if you might know. Walmart have their office over there. A lot of opportunities there, right? So that, yeah, I'm going to quickly go through all this. New York Stock Exchange generates about 1 terabyte of data, new trade data every day, right? Use this data to perform stock trading analysis. Yeah, it is something very, very useful for the finance domain, right? I remember I was working for JP Morgan when was this? This was 2006 to 2012 in Mumbai, and then in Pune, and then in Bangalore. And I know that, I remember that they used to have these monolithic systems, right? One system is in C++, the other one is in C, the other one is Java. One has some libraries, analytics module developed by some team, and one has another, and one has got some analytics data, and the other system has got another kind of analytics data. And then they had these, on top of it, Python applications and C++ applications that analyzes the data. The data was scattered all across the place, and it was a nightmare for them to manage, right? And when the big data started coming up in 2010, right, they actually adopted everywhere. And it's not only about the US context. Here also, in if you are in Mumbai, the Bombay Stock Exchange. Even Bombay Stock Exchange uses big data quite extensively. There's a Pune based company, Datamatics or something. I don't think I remember the name. They maintain the entire analytics system, the trading system of Bombay Stock Exchange. Right. So crazy amount of data being generated by these systems, and they would want to save and analyze this data, because you never know what kind of insights. If you go to Bombay Stock Exchange website, you will see whole lot of information there: the daily charts, the weekly charts, the trend of a particular stock, how it has performed in the last maybe week, month, year, 6 months, and all those kind of things. So I hope you're getting a sense, my dear friends, that big data is about huge amount of data, and your opportunity or your skill to analyze it so that you can do some kind of business augmentation. That is what is right. And we are going to talk more about it as I'm going to proceed. What are the other examples? NASA Center for Climatic Simulation stores 32 petabytes of data, comprising of climatic observations. Yeah, and that's the reason why when you go to US, if you people have traveled outside of India, you would see that the predictions are so accurate. Right? In US, people move out of the house by looking at predictions, and then say, oh, this prediction is right or wrong or correct. Maybe it is going to snow, so I'm not going to venture out. People make decisions nowadays. In India also, it is becoming quite accurate. If there is a cyclone, I think 2-3 days before, there was a cyclone in Bay of Bengal towards the Chennai side, and people were aware. So people were evacuated from the coastal side and all that. So see, its usefulness, right? Providing convenience to people. That much amount of data you can predict, you can analyze, you can foresee what is going to come and take decisions on the basis. In physics, Large Hadron Collider is let me just get the pointer, 30 GB of data. And nowadays, what kind of applications do you get? The other day, one of my friends who is very fond of astronomy and the stars and the moons and all that, he has installed one app on my on my phone, and through that I can just point it to the sky and the night. I'm sure if you have interest, you will also would have seen it, and I can find the name of every star or anything that I see in the sky. Right? How is it that people are able to come up with such accurate information? The position of moon, the position of sun, the position of all the stars, and whatever is there in astronomy. I'm no expert in that. Right? But people are able to gauge, to document, and present that kind of information, which becomes useful for you. CERN data center processes 1 GB per day, slightly lesser, but then a lot of medical research here also in India. As far as the medical research is concerned, Tata Institute of Cancer, Tata Institute of Cancer Research here in Mumbai, in Bangalore, there's a whole lot of research going on in the medical field to find maybe cure for the diseases which are which were uncurable, non-curable till now. Cancer, Alzheimer in US is now. Anything else that anybody would like to share, on the chat window? I'll be more than happy to hear you out. As Ashish Bhai was saying in the beginning of the presentation, if it is more interactive, if the session is more interactive, it will be more useful and become interesting also for all of us. Excellent. So yeah, please do go ahead and share anything that you would like on the chat windows for the benefit of everybody. I'm going to keep moving, right? And if I see anything on the chat window over the period of last many years, I have developed this ability to keep one of my eye, or one section of my eye on the chat window. So anything that you'd like to say, I'm going to just put my eye on the chat window and just keep looking at it. So please go ahead and share anything that you'd like to that I'm presenting. If you can just go through, there are many links that I've added, as you will see in the slides going forward. If you can go through that today after the session, it is going to be very, very beneficial and useful for you, right? As you will see that in my next example that I'm going to give you right over here. There you are, Google Maps. Yeah, so and then you will see I have this link over here. If you're interested, you go and read more about this particular example that I'm talking about in your in your free time. Right. This traffic signals in electronic city. If you're not from Bangalore, let me tell you, there's a place called as Electronic City in Bangalore, where Infosys and Wipro have started. They have fine-tuned their traffic signals, dynamic signaling technology. I'll tell you what it means. Right. This technology uses Google Maps, the information in Google Maps, and it actually tracks the kind of traffic which is present on those signals, 6 signals. In fact, it has been extended to more. This is something that I prepared in January. Right, and it'll look at the signals. Okay, it'll look at the traffic position, traffic intensity on the signal, and depending upon how dense or light the traffic is, it'll adjust the amount of time you have to stop for the green light. Right. When I read this, since I stay in Electronic City in Bangalore, I actually wanted to go and check it on those Siemens and Infosys signal, and I actually went and checked it at different times, and it actually comes into play. Right. 6 signals, these 6 signals, where if it is during the day, I don't have to stop for more than 15 seconds on the signal, because the traffic is not so much. If it is this is pre-corona times, by the way, January, February this year, when the corona was not so much intense. If you go to these signals at around 8 o'clock or 9 o'clock in the morning, there'll be the signal you have to wait for at least a minute, right? Without any physical intervention. It adjusts on its own. So that uses the data that is generated by Google. And Google actually gives you certain applications for free, like Google Maps. Behind the scene, the data that it collects is actually, gives a lot of API for a cost commercially for people to use and implement. And Electronic City LCTA, which is the body which manages traffic signals and a lot of other things in Electronic City, has purchased, and they've integrated that into their signaling system. Right. So you can read more about this in this link here. Let me just go, and I actually just have written the gist over here from that. The technology uses Google Maps to measure volume and speed of the traffic to dynamically regulate the timing on the traffic. You see what I'm saying, right? Due to this implementation, the wait time at these signals have become time specific. Yeah, I'm reading point C. This means that you might have to wait for some time during traffic hours, but not so much in off-peak times. Yeah, exactly what I was saying. Right? I explained it already, so I think reading it is a formality. Right? Read more at that particular link if you want. And if you go to that page in Google, you will see that police departments in US, they use it. In India, still not use it. Police department in US use it to locate the police persons if they are following any fugitive, any criminal, right? So that they'll come to know. If any policeman is hurt, they'll come to know. If they stop getting the signal, they'll come to know about it, right? Google Maps live location. Share live. I will talk more about it. So yes, a slightly more intense example I wanted to kind of show you guys over here. From now, please feel free to interrupt me. Take the example of Reliance Jio. Who doesn't know about Reliance, right? And who doesn't know what they have done since 2017? It was, I think, yeah, 17, and they came up with the the Jio mobile connection. I remember before the Reliance Jio time, I used to pay 100 rupees for 1 GB of mobile data. And with the introduction of Reliance, everything, we all know what has happened, right? You get 1 GB or 2 GB data per day, right? So how has that happened? If you have followed or heard the keynote address by Mr. Mukesh Ambani, who is the chairman of Reliance, when he was introducing Jio in 2017, he used a term. He said, since time immemorial, since my father days, we have been into the business of data. We have been into the business of petroleum products, right? The oil business. But for us, we have realized that data is the new oil. Right. There's a more potential in data, or maybe equal potential in data as of now, as it is in the oil business, right? And that's the reason why we're investing so much money in it, right? So my observation or my thoughts behind it was that at that point of time, how is it that Mr. Mukesh Ambani was able to make that statement? Data is the new oil. He had some thousands of data scientists or big data professionals accumulating data, analyzing data, telecom data, and finding out what are the pain areas. And what he has, one of the things that he realized is that data is something on which companies like Airtel and Vodafone are making money like crazy, right? And it is not that cost. It can be made or provided cheaper. Right, and they came up with this analysis, and that's what actually that kind of analysis is more something about something related to data science, and I wouldn't dwell much into that right now. It's a topic for another data science training. But the point is that they were able to come out with that insight, right, by analyzing and storing crazy amount of data, telecom data, and taking calls around. So data is the new oil. That was the statement made by Mr. Mukesh Ambani. And what happened after that, right? What happened after that? After that, after the introduction of Geo Fiber, there was a market disruption. Everybody brought their price down of everything, right? And they are doing the same thing with Giga Fiber also. Geo Fiber they call it, right? I mean, in Electronic City last year they gave me Giga Fiber for free for 6 months to use it, and it was an impeccable service, right? And after that, in January this year, I took it, right? I took a subscription or whatever that prepaid service is, and I am not sure if in this in my experience of 1 year it has gone down even one time, and it's critical for me in my business where I have to give presentation like I'm doing right now. Right, I cannot afford for the this. I've had a lot of issues with Airtel for that matter, and these guys would have done their research and come up with a technology which doesn't go down. Right. So same plans with Giga, with same thing they have done with the Geo Fiber. I should actually change the name there. It's not Giga Fiber. Yeah. Geo Fiber, they renamed it, rechristened it as I should say. All right, another one of my very very favorite example, Netflix. Who doesn't love Netflix, right? Do you know how Netflix started? Has anybody read about it? Netflix in US was a DVD rental service. I have written it down over here, and I've taken it from a link which you can, if you want to learn more information about these interesting, very very interesting organizations, exciting organizations, you can do that. Yeah, it was a DVD rental service. Initially they used to rent DVD. You pay, they will mail or post the DVDs in US. What happened in 2005 was that they realized something, and again, looking at their business data, they realized something. They said there is a potential in combining two things. One is high speed internet availability. 2005, the broadband came into the picture. Gone were the days at that time when you would still use dial-up. Dial-up was slowly becoming history, and people were venturing into broadband connectivity, high-speed broadband. So this said that people have broadband available. And the second thing is that the need for binge watch of content by the consumer at their own leisure. People want to see. Right now, I met a friend. Over coffee some couple of hours back while I was taking a break from my training, and he said, hey, you know what, I'd like to binge watch. If something gets very interesting, he was telling me about some series on Netflix. He said, if you want to binge, if you like some series, if I like some series, I better finish it, even if I have to spend whole night. Right? We all want to do that, and we all are in the habit of doing that. Right? I myself, guilty of doing that as well. Need for binge watch of content by the customer. So Netflix saw this as an opportunity, looking at the data, high speed internet availability, and the need for binge watch. Right? People like to do that at their own leisure, even if they have to pay a price for it. In TV, there'll be advertisement, and you have to wait, and all those kind of things. Right? So what they did is they came up with a subscription-based streaming service in 2007. Right? While decreasing focus on DVD business, they said that okay, DVD is fine, but then this is what is going to be our potential new business market, right? And what happened after that? 2007. For the next 5 years or so, while the streaming business, while there, I'm reading point D, right? If you want to read more, guys, go to the link on point J, right? You will love that. While the streaming business thrived, Netflix captured huge amount of data patterns and preferences of the users from its streaming service, and Netflix do that even right now, right? If you go to Netflix, I'm sure most of you would have, you will see lots and lots of information, right? Number one, series today in India, right? They'll give you, if you have seen, maybe 300, you would like to be, you would like to, watch Spartan, right? Or maybe, House of Cards or something like that. Right. So they give a lot of recommendation. They have these recommendation engines, and how are they able to build those recommendation engines, or how are they able to come up with those ideas like number one or number two in India? It's on the basis of the data that they are generating, they are saving, and they are analyzing. Right. Netflix keenly observed. So streaming service. I'm on point E over here. Sorry, it's a little long, but pretty interesting. During this time, Netflix keenly observed other trends. From 2007 to 2012, Netflix keenly observed something else. What was that? The popularity of series like Game of Thrones and Game of Thrones, and all that on HBO. 2011 it was. See, so what happened with Netflix? And this is interesting, right? In Britain, there was a very famous series on Margaret Thatcher, right? And the US version of it, adaptation of the US version of it, when it came available, when some production house came up with it, and in 2013, Netflix said that, okay, I'm going to do a multi-million-dollar deal and I'm going to grab it, right? Because I know that people will like to watch House of Cards all across the world because it's about US presidency, House of Cards. So Netflix got it, and from then onwards, this was in 2013, right? From then onwards, the concept of originals start. Netflix originals, and everybody copied it after that. That 2013 was the time when Netflix had only one original. That was House of Cards. After that, Netflix itself came up with thousands of originals. The meaning of originals is any content which is proprietary to that particular service. So apart from Netflix, nobody else can use this, what do you call, House of Cards, until the production house breaks the deal with Netflix and comes up with something. This is a multi-million dollar they have spent only for buying the production rights or telecast rights of House of Cards. Imagine how much money people put in, right? And just on the basis of their analysis, just on the basis of and the analysis on the basis of the data that they are generating, right? Netflix term this as Netflix original. I'm on point G over here, my dear friends, right? The concept of originals became an instant hit with HBO, right? And it passed partner Hotstar, and there are so many other series. If you're like me, you would know it, right? Handmaid's Tale, and a lot of other things. And now they're coming up with it in Hindi also, right? Sacred Games. The other day I was watching something called as, what was that? Suitable Boy. And later on, I'm on point I, Netflix integrated a machine learning based algorithm recommendation engine to user subscribe, right? Just to keep them hooked. See in House of Cards, maybe there are 10 things that you would like. And how would Netflix going to get the business if you renew your subscription? Their interest lies in, having increased subscription. So this is what the thing about Netflix. There are many more such case studies. I'm driving towards something. If I'm not able to drive that point today, we will do that tomorrow. We are going to start that tomorrow. Don't worry about that. Slowly and slowly, I'm driving you guys towards that point of what is big data. I'll just give you another like 1 or 2 minutes to just take a breather and just let me know if you have any questions. Anybody? Right. The idea, as I said, just going to reiterate. I'm going to build the context about big data to you right now, and then I will, tell you what is big data. Then I'm going to tell you the architecture, introduce the technology around those architecture, and then slowly and slowly look at those. That's what my. I'll give you like another 1 minute to just take a breather. I know it's too much of information. Just be with me. It will get over soon, and then we will move to So these case studies are like the ones which I presented over here were like the easy ones. You can just read it in bullet points. Like the examples that I've given over here have got links in them. The examples that I'm going to talk about right now are much more details, much more detailed or much more intense. And just let me quickly ask you all a question. It's been about an hour we've been in the session. Let me talk to you about something else, and I'm going to play some videos over here. Right? Let me do that. All right. We all know about, and this example is from the FedEx, from the logistics domain. And this is actually something that I have prepared especially for, for the Mercedes-Benz people, because they asked me to specifically ready something which is with respect to the logistics domain, distribution and supply chain. So FedEx, we all know, is into the business of couriering and distribution and logistics and supply chain. So and they've been there since time immemorial, like since last many years, right? So FedEx, from last so many years since they have been in business, they have actually generated a lot of data. And one fine day they thought that, I'm just giving you a background. One fine day they thought that maybe generating data is not enough. Maybe we need to analyze it. And when they just sat and analyzed it, they realized that maybe they can come up with some value-added service, right? And they came up with something called as SenseAware, right? And SenseAware is you'll come to know about it. I'm going to play a video, for you all, right? So just give me a moment. Let me just go through these, points one by one. Handling so many millions of shipments a day. All the generated data gets saved for analysis further on. That's what FedEx is doing. But FedEx wasn't only storing data. It recognizes the potential behind it. Therefore, it has always looked for opportunity to use the leverage data. And what do they use for? To come up with these kind of products that I'll be introducing to you right now. Quite recently, not very far ahead in the past. It has used all the stored data over the years to build a next generation, first of its kind information set, right? Here is the video to understand it better, and here is the link to the website to see how it works. Let me actually play the video maybe first, okay? Just click here. I hope you are still with me. That was about what SenseAware is all about. right? How it puts those devices in your shipment, and then with devices and GPS you can, that is a GPS device, and the GPS device you can find out what is where your shipment is, and that might be important for people. I mean, think about if you're sending your some important documentation like your academic details from one place to another. You would want to locate it, and you would not want to get lost somewhere. So what FedEx does is, with sensor, where it puts that device in that particular box in which it puts your shipment, and with that it actually locates it from locates it everywhere, right? Let me just go to the website also and open it for you and show you how it looks like. Yeah, I'm going to the website here. Somehow it is not opening up. Let me see. Yeah, all right. Somehow it is not opening. Let's see if I can open it on Safari. Proved to be lucky for me. Yeah, this is what all you can do. Program journey, invite stakeholder, the journey of your shipment, activate and pack, monitor and receive alerts, collaborate, unpack and return, generate reports, improve efficiency, right? What are the kind of services you can get? Subscription based or one time single journey for your shipment, right? What does it, what is the kind of statistics it gives you about your shipment? Temperature, humidity. You could be sending something which is medically sensitive. I mean, in these COVID days, you might be passing on information of your whatever vaccine or whatever research that you are doing, right? So you would want to know whether it has, it is saved or preserved while it is in transit. Shock. It might be something fragile, light exposure, right? Or more importantly, current location, where you're shipping, and you would want to know that as well. So, FedEx came up with the service and then they commercialized, right? So people use it by very very extensive. It's not only about sending your shipment from one place to another. It's also about tracking your ship and tracking all these statistics about your ship. Imagine the kind of value added service provided. So that's how analyzing the your data can change your business, right? One of the changes that you can introduce in your business is to come up with value added services like FedEx did, right? FedEx came up with something like they said sense of where it is going to give you additional statistics, and you might have to pay the price for it, but people are willing to pay the price, right? Don't have any issues with that. So that is one very very interesting case study. I have put all the links in the slide, right? If you want to explore more, and I would suggest you spend time today to explore this more, you will get a better idea. Yeah. So that's that. I'm just going to close this because it's somehow not opening, and I'm just going to make this full screen back. Yeah. Now let me talk about something else. I showed you an example of Google Maps some time back, and how Google Map is basically helping you share live locations or managing, let's say, traffic signals, which is, by the way, just only one of the examples. But what is Google Map as a product, right? I'll just come over here and talk about. Yeah, I've already told the details of the slide, so we won't go to it right now. We'll probably come here, right? So I went to the Google website to to generate to collect this information. I put the link over here. Click on the link. It should open you the 101 from Google itself. Here is how we map the world. Right? It's a long article, right? You can read it at your leisure whenever you want, but it's very interesting to read. I did this in January sometime this year and found it to be something very useful. Well, so what does how is Google Map made, and how do they make use of big data? So basically, they have divided everything into four: imagery, data, yeah, your imagery, your data, your human factor, the people, and machine learning. Right? So let's go and find out what these things are. What is imagery? Obviously, they will take images from the satellite, right? Launched in early 2000, it shows where the roadways, building, and addresses and business are located in the region. Like, for example, in my and I'm sure you can also see this in my Google Map. I can see the location and actually see my building in it, even my swimming pool as well. I can see that, right? So, how does Google take those pictures? Google takes it by the cameras which are there in the satellites, which are there in the space. Additionally, these are just the gist. If you read that article, you'll get that more in detail. But if you, in case you find that you don't have time to do that, you can, just read this. It also shows other important detail as such as town speed limits of business names, right? So here in India, we don't have time limits. But when I go to Sydney, for example, for my trainings, I'm told that on a particular road, this is the speed at which you have to drive, 80 miles per hour. You drive slower than this, you will get into two problems. One is you'll get a ticket, traffic police ticket, that you were driving slower. And second, on a bigger problem is that somebody who's driving at 80 might come back and might come and bump you. right? Crash you from behind. That is more dangerous, much more dangerous, right? So you have to maintain that speed. The concept is not there in India because obviously it's a very populated, we live in a very populated, loving country. In some country, wherever it's applicable, it does that as well. The second part of imagery is, which has come, I think, later, 2007, right? After 7 years, is the street view, right? In 2007, street view was launched to help people virtually explore the entire world, from the depths of Antarctica to the top of Mount Kilimanjaro. It has been 12 years since then. Actually, it has been 13 years. Street view car and tracker operations have collected more than 170 billion from 87 countries. They have something called as tracker device. Here is the tracker device, by the way. It looks like there's a little bit like robot. People actually take images with this. People who work for Google, and then they put that in the for the street view. If you are interested, you can read more about it. I got interested and I read about all this. Yes, and there's a chance that if you go through it in the detail, you might get into more details as well. And that is equipped with high resolution sensors and increased aperture. The quality of imagery captured by Google has significantly improved in Google Maps, right? And you would see that, right? Google Maps they are innovating. Of late, I saw a feature in Google Maps, and again, I hope we are not going out of the context. But again, all this is they are doing on the basis of the tremendous amount of data that they store and research upon, right? Right, which is basically the next part over here. And so let's move on to that. Data, right? Which is why we are here. Data for Google Maps comes from more than 1,000 third-party sources from all across the world, right? For example, I don't know whether you know this or not, but and I saw this in Sydney and I experienced this in Bangalore and Bombay also. If I have to go from place A to B in all these three cities, I can map that on my Google Map on my phone. It will tell me the entire route. So in Sydney, it will tell me how much I have to walk and then what time I'm going to walk to the bus stop, at what time the bus will be coming, right? And it actually does come at that time in Bangalore, in Mumbai, and in Sydney. And from by taking that bus to which place you have to get down, and from there you'll get a train, and from there you'll get a ferry and whatever, right? So you can plan your journey around, right? So that kind of data, that kind of information, imagine how useful it is. When I am in Sydney, I don't have a car, so I travel on my own. So this thing becomes very, very useful. Government bodies like United States Geological Survey (USGS) and the National Institute of Statistics and Geography in Mexico provide information about the entire country. So how these cities like Sydney, Mumbai, and Bangalore are able to give the relevant information about when the bus is coming or a train is coming. The government organizations here, like BMC here in Mumbai or BMTC in Bangalore, passes on the information to Google, and Google punches that information, the real time information. Google punches it into the application, and there's this understanding between Google and these government bodies. Maybe government bodies, Google pays government bodies for that. They would have that kind of contract between them. Right. So next time when you're taking a bus in your city, try that. Or going by public transport, try that. Right. It might be there in Delhi. I don't travel that often to Delhi, so I don't know. Since looks like most of you are from that area. Data, right? Others are specific to a smaller region, like data from local municipality or an NGO or a housing developer. In fact, I'm not sure if you are aware, you can also register yourself as a volunteer to collect data for Google. If you go to the Google website, you can do that. Then what happens is Google does some stringent data vetting process, and you cannot give them any information, right? They need to validate it as well, right? So they have a team which does that. New tools available for government to upload data. They said, okay, we'll make it easier for you to upload the data. All you need to do is use my tool to update that. That is what. So that is about the data, imagery, data. What is the third point? Human factor. Right. Imagery and data are no doubt the key components of map making, but they are static and cannot keep up the pace of the ever-changing world. Here comes the third important facet of Google Map: the people that help tie everything together. Right. I'm over here on point B, just in case if you're lost. Google had data operations teams staffed all across the world that plays a role in just about everything, right? It's about every aspect of map making, from gathering street view images and vetting authoritative data sources to correcting the map for inaccuracies and training machine learning, right? It's an extensive case study. Read it later on, guys, when you have time. Google also has a community of local guides and Google Map users. Like exactly the thing that I was saying, you can volunteer yourself, right? Who are empowered to correct the map via the send feedback button in Google Maps, right? Google team reviews the information and publishes if it has high degree of confidence that it matches the road, business, and addresses, right? So there's a vetting team which you upload the information, vetting team will vet it and they'll let you know whether it's right or wrong information. right? The human factor. So Google cannot do it without a team of people who are going to help them out, right? The fourth point, machine learning use, right? Machine learning usage. Now, how does Google use machine learning, right? I'll give you an example. To increase the speed of mapping, Google turns to machine learning, right? Machine learning allows the team to automate mapping processes while maintaining high level of accuracy. How is that? For example, previously an algorithm that tried to guess whether a part of image was a building or not, resulting in what we dubbed as clear and unfuzzy image. Suppose they've taken something like this, right? Fuzzy image. They look at it and they say maybe things are not very clear. What they will do is, to fix this, Google worked with data operations team to trace common building outlines manually. Go there and outline them, right? So maybe if in an area there are like 50 buildings, they'll go and outline, make a sketch of maybe 5 buildings or 10 buildings, right? Feed this information into a machine learning algorithm, and then machine learning algorithm is going to give a better picture. Image corresponds with the building edges, which basically gives you a better picture. So here is what it was for Google without machine learning. Fuzzy images, they did this. I'm going to come back to that, and they came up with this much more clearer picture, right? Without getting too much into details, if you know a little bit about machine learning, this is the machine learning process. Right? Don't get too overwhelmed by this. You have historical data. Basically, it's in two parts. You do something with the historical data, you do something with the real-time data. With historical data, you build model for prediction. With real-time data, you feed the real-time data into your model and you get predictions. That's simple. I'll repeat a little slowly. With historical data, you build a model, right, for prediction. This is a particular area, what it looks like. The clearer one might look like a little better. So feed that information, you'll get everything clear. So build a model for prediction and use that with the live data to get your predictions. And that's what machine learning in gist is all about. Right? So you can read books, forever on that, but in gist, this is what machine learning is all. Yeah. So I was here, right? That's how. So Google Maps is basically a product of these 4 parts: imagery, data, collecting images from the satellites, capturing data and analyzing it, the team to do it, the human factor, and the machine learning model usage of machine learning model to further improve your predictions, right? This is a very interesting case study, my dear friends. If you really want to get to read it, click on this link. I would suggest click on this link and read the entire. It will help you understand what how big data can really be useful, and again relating to something that we use in our day-to-day life. Your what do you call your Google Maps. I use it day in and out. I hope you also uh, do the same. I'll just give you another few minutes to just digest all this. I think I'm done with most of the case studies. I think I'll tell you about Vimo also. Google Vimo. I think in today's session we'll touch a little bit about formally what big data is. Tomorrow we'll dive deeper. But I suggest you guys go through the recording. You guys go through the details that I'm telling you to do, so that it becomes easier for you to catch up tomorrow. Yeah. Okay. Let's go ahead and do this. The Google Vimo project. And again, I'm going to play a video. I'm sure you would have heard about Vimo. Why don't I go ahead and play this video right now? Very nice. Whenever I play this video, I actually feel very good about it. It's actually a very good video. Vimo is actually live in US already. I think some of the cities in US it is already live. In sense, people are using it. So yes, let me just go ahead and tell you what it has said in the presentation right now. I just went ahead and jotted down everything in this slide. What does it do? It does the light detection, first of all. Light detection and ranging. Using sensors such as radars, camera, etc., the vehicles are able to create a short distance understanding of its surrounding in real time. You would have seen in the video, when the cycle was coming, or what all cars are, are parked. It nicely dodges them, right? And it can see that, it said in the video that it can do that for three to the distance as long as 3 football fields. So that longer distance, right? So that is one thing it does. Second is mapping. Right? What kind of mapping? The vehicle's computer must possess and have the ability to process highly detailed, comprehensive map of street features, including street light, signs, road, and curves. Right. So mapping the road and understanding which lane is going where. The third is the vehicle-to-vehicle communication. Made possible as cars are fitted with computers having internet. Yeah, the cars are having internet wherein cars can communicate with each other to find out those distances where what vehicle is, right? And last but not the least, sense, plan, and act. Now to plan and act in a timely fashion, the weakest machine learning algorithm must be able to predict the outcome based on high volume of data. It does exactly that to weight pass through the different type of scenario. So it looks at a scenario, it takes that into account, feeds that into a machine learning algorithm. With the help of that machine learning algorithm, it says, oh, you know what, I have to take a left turn or a right turn or stop or go ahead in the most safest manner. Right. So I think the other sense that you might get from whatever I am presenting right now is that the big data world, the big data part, is something that is related to machine learning. In fact, I should say the other way around. The machine learning world is also related to big data. Big data stores the data, you analyze it. Machine learning predicts. It's actually very, very simple, right? In big data, you save the data and analyze it. In machine learning, you predict, right? As Mr. Vinod is asking, can you please repeat way more, right? It's very, very simple, Mr. Vinod. You can read what I have written in the slide. It's very, very simple. The use of data to automate your car and make them driverless. That is what Waymo is. The car can be driven without driver. You see what I'm saying, Mr. Vinod? Yeah. So
Yeah,
the concept of the driverless car, and also there is all these slides, Mr. Vinod, have links also. So if you've missed anything, just click on the link. Like for example, this slide has got this link over here. Just click on it, and the video will start. Just go through the video. All right. Okay. Okay. How much is the time we have? We have about we have some time. I can where we are right now. Let me just take a. Okay. So one last example, and then we'll move on, right? And that example is about from very interesting movie industries, right? Big data is used in the world of movies also nowadays, huh? And that comes as a surprise. That I'm not sure if that is going to come as a surprise to you or not, but it definitely came as a surprise to me when I read about it. There's a company, and I read this in the Hindu, Woodcutter Films. There's this company called as Woodcutter Films. They are based in Hyderabad and Bangalore. So what do they do? Interesting people, huh? They are from IIT Madras and all that. I'm just going to read it out and give you more background as as we read this more. They're based on the idea of unpredictable nature of outcomes for movies in terms of success or failures, right? It's very unpredictable, right? Any movies can bomb, right? Any movie in the world can become a hit, and any movie in the world can bomb. So how would you make out whether a particular movie is going to be a hit or a flop, or how can you make sure that you put maximum effort to make that movie a hit, because there's $1 million investment that has been done into them, right? So here also the same thing happens. I'm reading point B over here. The CEO of the company himself suffered a failure with one of his movies with Dhanush. I'm sure you would know who Dhanush, the South Indian star. His movie, although critically acclaimed, bombed at box office in terms of revenues. Right. Armed with technical background, the CEO of Woodcutter Technologies set up a team in Hyderabad with 5 data scientists from IIT Madras to amalgamate, to mix his creative and technical talent with data analytical skills of his team. They started with a project of descriptive analytics on this movie called as Futre Returns in 2017. Promotions from Excel Entertainment. So they took promotions, okay? And what they did was the team, I'm on point E over here. The team analyzed the audience reaction, right? They had, for the trailer, they just put some people in the in the room, sample people in the room from the teaser of the movie, and made relevant suggestion to Excel Entertainment on what kind of actors and dialogue to highlight in the trailer. So they analyze the with the help of cameras, mimic detection and all. They analyze the expressions which are coming on people's faces, right? And said, okay, this is the part of the trailer. This is the part of the trailer where audience were looking most interested or happiest or feeling good about it. Continue on with it. This is the part where they were looking not that interested, that invested. Remove it. Those kind of things. And they retrofitted the trailer. They said, okay, this is the part which are not working. Let's go ahead and remove them, and which is the part where working. Let us put more of that in the trailer. What happened is the movie. I'm on part point F over here. The movie scored 76% on Book My Show, 65%, 6.5 on IMDb, and 92% like the movie on Google, right? So with that, they got encouraged, and that's the reason I've written humble beginning, right? They said, okay, now this there looks like a scope, like some scope in this work. Let's do one thing. Let's build a model, maybe a machine learning model based on the data that we have, using box office numbers and data from movie distribution from all across the globe. Yeah, data is available. Crazy amount of data is available for free for you to analyze, right? I'll share many links with you from where you can download the data and analyze yourself. You go to Kaggle website, you can download so much data from there and use it. Now they made it this model, and the model identified unsuccessful patterns in the script, casting to predict success for probability. They said, okay, this is the model. This will tell you whether with these many variables, this movie is going to be, or trailer is going to be successful or not successful. The model identified, yeah, they combine it with another AI-based computer vision model that that captures emotions of the characters of the right. The company's success prediction with accuracy rate is in the next slide. Here is the link which you can, wherein you can read more about it. I went on the net and actually found the link for it, and I have put that for you all over here. This is their success rate. You'll be able to see how much accuracy, with how much accuracy they have been able to predict the success or failure of the movie. Sanchi, Amar Akbar, and the new one, not the Amitabh Bachchan one. Taxiwala 2018, Antriksham 92%, and some other, like mostly I think it looks like South Indian movie. But imagine people like Karan Johar and all are not very far away from these kind of people, right? Because they are investing $1 million into into these movies. So why would they not go ahead and get something which is a little more predictable about?